All right, welcome back everyone. This is Noah, and let's look at the solutions to the Now You Try problems where we're adding and subtracting rational expressions and looking for domain changes. So the first problem we're going to look at here is 4a over a plus 1 minus 2a minus 2 over, once again, a plus 1. So we've already got a common denominator. We don't need to worry about that. So I'm just going to look at that first, or combine these fractions now. A plus 1 is our common denominator, so I can bring that down. Then we want to go 4a minus 2a is 2a. And then the minus 2 on top, the negative also distributes to that, so that becomes a plus 2 up there, right? Minus negative 2 becomes a plus 2. And so then we'll go ahead and factor the 2 out of the top, leaving us with a plus 1. And on the bottom we had an a plus 1. And so we can cancel those a plus 1s, top and bottom, leaving us with just a 2. So the domain of the original subtraction equals the set of a values such that a does not equal negative 1. And that doesn't change at all for the first 3 steps. It's not until the last step where we get a domain change. And we can say that these are equal unless a equals negative 1, where they are no longer the same because we cancel that a plus 1 out of the denominator. The domain of the final expression, that's all real numbers. There is no denominator. I could plug in any a value. I can plug in any a value and I would always get 2 out. It's a little weird to think of it like that, but if I think of this as like a function, right? Say f of a equals 2 as the function, then I could say f of 5, well, that's 2. F of negative 8, that's still 2, right? So that's how we're interpreting that 2 there. Cool. All right, that's it for that problem. Let's go ahead and move on to part B, where once again we are given something that already has a common denominator. So we don't have to worry about that. We've got 3w plus 6 over w squared plus 2w plus 1 plus, second fraction, negative 2w minus 5 on top over w squared plus 2w plus 1 on the denominator. We can bring these together as a single fraction, w squared plus 2w plus 1 in the bottom. On top, we'll combine the 3w and then plus negative 2w gives us just a w. And we have a 6 plus negative 5 will be a positive 1 on top there as well. All right, next line. We'll go ahead and bring down the w plus 1 on top. On the bottom, we want to factor the w squared plus 2w plus 1. This will factor with the w in the first positions, and then we have to have a 1 in the second positions. If both of those are plus, then we will have a 2w in the middle. Oh, this is kind of cool. The w plus 1 on w plus 1 on top, and one of the w plus 1s on the bottom cancels, leaving us with a 1 on top. So our final expression will be 1 over w plus 1. And the screen is still glitchy a little bit. My hand touches it and it goes sideways. Let me try this here. Quick, 1 second. Okay, I don't know if that fixed it, but we're going to try. I just closed the software and reopened it while the video was paused. So for all of these, the domain is the set of w such that w does not equal negative 1, right? That's the only value that w cannot be, which we can see at that point. But it doesn't change. There's no change here because even on the bottom line, w still cannot equal negative 1, right? So the domain is the same for all of these. Cool. right, let's do part C down here. We have 4 over x squared minus 4x minus x over 4x minus 16. We'll start by factoring the denominator of the first one, x squared minus 4x. We can pull out an x. We'll be left with x minus 4. On top, we'll keep that 4. We'll go minus x over, the denominator of the second one is 4x minus 16. Here we can factor out a 4 and be left with x minus 4 again. So if I go to the next line and I think about what is the common denominator, we're going to have a 4, we'll have to have an x, and then just one of the x minus 4's. Right? That's already common to both of them. We don't need to tack another one on. And so that'll be the same in both denominators here in a second. 4x times x minus 4. Now to get there in the first fraction, we need to multiply by 4 top and bottom. In the second fraction, we need to multiply by x top and bottom. This is going to leave us with a 16 on top of the first fraction from 4 times 4, and in the second fraction we'll have an x squared from x times x. We'll come down and we'll bring these together as a single fraction, 16 minus x squared over 4x times x minus 4. And then we want to factor the numerator here. That 16 minus x squared will be a 4 minus x, and then a 4 plus x, all over 4x times x minus 4. Now we look and notice that the 4 minus x and the x minus 4 are the same, but opposite orders. So I want to flip one of them. I'll flip the top one to make that a minus parentheses x minus 4. So I can switch the order and put a negative in front. If you skipped the lecture video, I went into detail on why that is and how we can do that. So make sure you've watched that video if you haven't already. So we flip that, make it x minus 4, put a negative in front, bring down the 4 plus x, and then in the denominator we still have 4x times x minus 4. So we can cancel the x minus 4's here, and we will be left with negative 4 plus x on top, in parentheses, over just a 4x in the bottom. So we don't cancel anything into that last step. So right here, these are equal except if x equals 4, at which point they differ, right? Because the top one would be undefined when x is 4, while the bottom one is perfectly defined when x is 4. We could plug that in, no problems. So the domain of the first 4 is the set of x such that x cannot equal 0 or 4. And the domain of the last one is the set of x where x cannot equal 0. That's the only restriction there. Sweet. All right, one more problem here. Where'd it go? Scrolling up. There we go. All right, so the long one now, we've got 3x minus 1 over 4x squared plus 4x plus 1 plus x squared plus x minus 9 over x squared, 8x squared plus 10x plus 3. All right, we want to start by factoring everywhere that we can. So the first fraction, the 3x minus 1 on top, is going to stay the same. On the bottom, 4x squared plus 4x plus 1. Let's see if we factor this. This one could be a little tricky because the 4x squared could be a 4x and I could do just a 4x and an x. But I don't think that's the way this is going to work. I think this is a perfect square scenario. So I think we're going to do a 2x and a 2x and then a 1 and then a 1. And then let's just check. We have a 2x and a 2x. As long as those are both positive, we'll have 4x in the middle. We'll go plus the second fraction, the numerator, x squared plus x minus 9. This looks like it might factor. X squared, well, I need a negative 9. My options are 1 and 9. And neither, like if I did a minus and a plus, that would be an 8. Or I could do 3 and 3, and if I did a minus and plus, that would be a 0. So that actually doesn't factor there. So we'll just bring it down to x squared plus x minus 9. The denominator, though, let's see what we can get out of this. I'm going to use the AC method on this denominator. So I'm going to bring it over to the side. Let's get that up there. So I'm going to go 8x squared plus 10x plus 3. I'm going to do 8 times 3 is 24. I'm going to look for two factors here. I'm going to do 1 and 24, or 2 and 12, or 3 and 8, or 4 and 6. These are different ways of multiplying to 24. And I want to find 2 that add to 10. So positive 4 and positive 6 add to 10. So I'm going to break this up as 8x squared plus 4x plus 6x plus 3. And then I can group the first two and group the second two. The first two group, pull out a 4x, and I'm left with 2x plus 1. In the second two, I can pull out a 3, and I'm left with 2x plus 1. So move this out of the way a little bit. And then we can pull out a 2x plus 1 here, and we'll be left with 4x plus 3. So that's the AC method. That's the other way that we could get through factoring one of these guys. So I'll write that 2x plus 1 times 4x plus 3 in that denominator. Cool, so now I can factor, or focus on getting a common denominator now. The common denominator we want, well, the 2x plus 1 shows up in both of them. In the first one, we've got another copy of 2x plus 1, so we'll put another one down there. Then we also need a 4x plus 3. So I'll write this again for the second one. We've got 2x plus 1 times 2x plus 1 times 4x plus 3. And again, I want to make a little more room here. This problem's no joke. We've got some work to do. All right. So the first fraction, we needed to tack on a 4x plus 3 in the bottom. So that means I want to multiply by 4x plus 3, top and bottom of this fraction. Let's distribute that out. That's going to give us a 12x squared, and then plus 9x minus 4x minus 3 when I FOIL those. For the second fraction, we need to tack on a second 2x plus 1. And this is going to be a long FOIL here. We're going to have a few terms for sure. I'm going to have a 2x cubed. And then we're going to have a plus x squared. We'll have a plus 2x squared, a plus x, and then we'll have a minus 18x and a minus 9. Ooh, long one. Okay. Let's see if this simplifies nicely here. So I go to my next line. I want to bring these together as a single fraction. 2x plus 1 times 2x plus 1 times 4x plus 3. And in the numerator, we'll have 2x cubed. I want to add my x squareds together. I've got 12x squared. Then another one, 13, 14, 15x squareds. Then my x terms, I've got 9x minus 4x is 5x, and then another x is 6x, and then minus 18x is minus 12x. And I've got a minus 3, and a minus 9 makes minus 12. And yeah, I think we're really stuck here. Like, I would love if we could do something with this, but I can't factor an x cubed. Like, I mean, I could pull out a 2 on top. I could make that a 2. Oh, no, because it doesn't go into 15. So we're really kind of stuck here. There are some advanced methods that we could use. Like, if you take Math 111, you'll actually learn some ways of maybe dealing with that 2x cubed plus 15x squared minus 12x minus 12. But they're pretty complicated, and that's not the point of this lesson. So we're just going to leave as is. So no factoring of a cubic, right? That's the with an x cubed term. So no canceling. So the domain of all of these is the same. Domain never changes. Domain equals the set of x such that x cannot equal -1/2 or -3/4. And that never changes. In this simplification. And so just to be clear, the 2x plus 1 cannot equal 0, and the 4x plus 3 cannot equal 0. So that's how we're getting the -1/2. And then 4x cannot equal -3, so 4x x cannot equal -3/4. Cool. That's it. There's no actual domain changes to note for that one. And there's nothing watch. Bye.